So for example 4, let's do sine 2x equal to cos 70. And now I'm also going to add one extra element to this. I'm going to give an interval for x. We are going to have to give specific solutions, okay? Because so far we've only done general solution, and you do have to know how to do the specific solutions as well. Now guys, do I have a sine equals sine? I have a sine equals cos. So I can't actually just say that this is going to be my reference angle, because sine equals cos, it's not the same trig ratio, okay? Can I change cos 70 so that it's a sine instead of a cos? Yes, good. So I'm going to rewrite cos 70 as sine of 90 minus 70. Do you remember co-ratios from last year? As soon as you do a 90 minus, you have to change your cos to a sine. So this is actually going to give us sine 20. Guys, if you're on a test or exam and you're not sure whether you've done that co-ratio thing correctly, literally take your calculator. Okay, no one's going to know. Take your calculator and type in. Oh, what's this? Wow, sorry. Okay. Type in cos 70 equals 0,342. Sine 20 equals the same thing. Okay, so you can literally just do a quick check to see if cos 70 actually is the same thing as sine 20. All right, the important thing here, guys, for these questions where you are not using your calculator, you have to have a sine equals sine, or a cos equals cos, or a tan equals tan. Okay, we haven't done tan examples yet. We'll get to that just now. But you have to have the same trig ratio on both sides. So I'm just going to make a note here. Have to change to sine. All right, you need the same trig ratio on both sides. Otherwise, you can't just say that it's going to be your reference angle. It's like if you have a 3 to the x equal to a 9 to the 4. You can't make those exponents the same, right? You have to have the bases the same first. Okay, same thing here. You have to have the same trig ratios. So now what is my reference angle going to be, guys? 20. Okay, so the reference angle is 20 degrees. And this is saying sine is equal to positive, right? Positive. Where is sine positive? In which quadrants? 1 and 2. So we're going to have a quadrant 1 solution and a quadrant 2 solution. So in quadrant 1, we're going to say, what is the angle now that was after the first sine? 2x. So that is equal to the reference angle 20 plus 360n. And now to get x on its own, I need to divide by 2. So 10 plus 180n. Quadrant 2, 2x is equal to 180 minus the reference angle. Remember, that's what we always do for quadrant 2, plus 360n. Before I divide by 2, I'm just quickly going to simplify this. 180 minus 20 is 160, right? And now we're going to divide by 2. So x is equal to 80 degrees plus 180 n. Okay, now that is the general solution, guys. That is what we've done up until now. But now they've said that our x answers, right? Our answers for x have to lie between 0 and 360. So they actually want specific solutions. Okay, so what we're going to do, we're going to use our two kind of final general solutions, this 10 plus 180n and 80 plus 180n. We are going to use those as formulas to calculate specific x values that lie between 0 and 360. Okay, so these two are formulas to calculate specific solutions. And the specific solutions have to lie in that interval there that they've given us in the question. All right, they can give you different intervals. They can say negative 180 to positive 180, 0 to 540, whatever. They can give you any kind of interval of values. Okay, now guys, this is now where the n comes in. We are now going to sub in values for n. So I please want you to have your calculators on hand. I want you to type in 10 plus 180. And some of this you can kind of just do in your head as well, all right? But for the purposes of this, we are going to use our calculators. Now, guys, what is n again? N have to be, or the n values have to be integers, right? Now, integers are positive or negative whole numbers and 0. So start with 0, guys. Equals, what's that? 10. Is 10 between 0 and 360? Yes. So you are going to write, therefore, x is equal to... Now, we are technically meant to use curved brackets because we're going to list the values in kind of any order, all right? But it's also, I suppose, fine if you just list them. But yeah, let's use the curved brackets. So 10 was the first answer that we got. Yeah. It depends on how many values fit in the interval. It will be different. Yeah, it will be different every time. Now, guys, don't clear this. You've already typed in most of the things. What is the number that comes after 0? 1. So now I'm just going to use my arrow button. I'm going to go to the 0, delete it, and put in a 1. 190. Is that between 0 and 360? Yes. So that is the next one that falls into this interval. Now let's make n equal to 2. 370. No, that's too big. Okay. Now, guys, we've subbed in 0 and we've subbed in positive values. We haven't subbed in negative values. So let's just quickly check. If I change this to a negative 1, what am I going to get? Negative 170. Does that fall into my interval? No. Okay, so I'm done with that first equation. All right, I got 2 answers from that first equation. You are only going to sub in whole numbers, guys. You're not going to sub in like a half or a quarter. All right, n has to be an integer, so whole numbers. All right, now we need to do the same thing with the second equation, the 80 plus 180n. So in your calculator, you're going to type 80 plus 180 bracket, make n equal to 0 first. 80 degrees, does that fall in my interval? Yes. What comes after 0? 1. 260, is that in my interval? Yes. If I make n equal to 2, it's going to be too big, hey? 440, that doesn't work. Guys, if I now, because we did 0, 1, 2, if we go to negative 1, I'm going to get, a negative number, which also doesn't work for the interval that they gave me. Okay, so we only have these 4 specific solutions. So guys, I'm just going to write where each of these values came from. So the 10 degrees we got from the quadrant 1 solution when we made n equal to 0. I would like you please to write this in as well so that when you look back at these examples, you know exactly what we did. For the 190, also the quadrant 1 solution when we made n equal to 1. The 80 we got from the quadrant 2 solution when we made n equal to 0. And the 260 was also from the quadrant 2 solution when we made n equal to 1. Guys, you keep going, you keep subbing in values until you get values that are too big or too small for your interval. Okay, it will depend on the question.